So this partial fraction decomposition is a little bit different because you have to factor the denominator by grouping. So looking at the denominator, and you may or may not recall the factoring technique of grouping, but if you group these two things sort of together, what you can do is factor out an x squared from the left-hand side, and you get x minus 1. And if you factor out a 4 from this right grouping, you get x minus 1. So now you see you have a common factor, and that common factor is x minus 1. So if I factor the x minus 1 out, I'm left with x squared plus 4. So that's your factoring, and everything else pretty much continues the way we've been going about solving partial fractions. So you're going to break out your factors. And I think it's worthwhile for me to just complete this problem so that you get another chance to be exposed to this material. So on the left-hand side, you just have the integrand that we're decomposing. And on the right-hand side, we have a over x minus 1. And this is an irreducible quadratic, so we have to handle that by decomposing with this term. So we've got slightly different problem than we have been used to, but again the process is the same. We're going to multiply through by the denominator, which is x minus 1, x squared plus 4. And I just rewrote it in a different way, but you know that cancels out because we just went through the factoring process. So what you're left with on the left-hand side is simply x squared, and on the right-hand side you're left with x squared plus 4, and on the right-hand side you're left with bx plus c x minus 1. So let's go about collecting terms. I think that's, maybe not. Let's choose picking values for x. Let's go down that route. So let x equal 1 because I'll be able to knock out this term. Okay? So if we let x equal 1, we get 1 squared is equal to 1 squared plus 4a, and then everything over here is going to cancel out. So we're just left with this, right? Because this is bx plus c times 0. So a is equal to 1/5. And all I did was solve the equation. So let's try and knock out another one. Okay, so we're having a little bit of difficulty here. What I think I would do at this point is if we let x, and if we can't knock something out, we try and let x equal something simple. All right, and x equals 0, x equals 1, they are simple values for x. So let's try x equals 0. Okay, we get 0 squared. 0 squared plus 4a plus b times 0 plus c times minus 1. So solving this equation, you get c is equal to 4/5. So that leaves the task of trying to find b, right? So if I let x equal 2, and again, there's many ways to do this. I'm just flying out of the seat of my pants here and figuring out what I can easily let x equal. And collecting terms may have been a better way to go. I'm not quite sure yet. Alright, so I'm just letting x equal 2 in this equation now. And then I'm solving it for b. So I get, let's see, 4 equals 8/5 plus 2b plus 4/5. Okay, so b is equal to, and I'm doing a lot of arithmetic in my head, but I think b is equal to 8/10. Yeah, which is just 4/5. Okay, so now I've got my coefficients. So let's put it together and integrate. So this becomes 1/5 over x minus 1 plus 4/5 x plus 4/5 over x squared plus 4. Okay, so this is just 1 over 5 x minus 1 plus, I'm going to pull out the 4/5 because it's a lot easier, and I'm left with x plus 1 over x squared plus 4. So this is a little bit different. What I would do here, U substitution fails us, so what I would do at this point is split fractions. So let's go down that route. Let's split fractions. So I've got I'm going to rewrite this. I'm going to pull out the 1/5, 1 over x minus 1 dx, right, plus if I split the fractions out, I'm going to end up with 4/5 x over x squared plus 4 plus 4/5 1 over x squared plus 4. So that's simply a splitting of the fractions out. Okay? So I'm going to pause here for 1 second. Okay, so we have these three separate integrals, and this is easy. Right? This is just 1/5 ln of x minus 1. And here, we've got to do a u sub. And here, what does that look like? Tangent inverse. Okay, so we've got really three separate integrals to solve here. So with the u sub, we're just going to let u equal to x squared plus 4, and du is equal to 2x dx. Right, so that's going to be 4/5 times 1/2, because I'm going to pull out the x, and then this is the integral of 1 over u du. So I'm just working them side by side. Oh, I'm running out of space. Okay, so this is 1/5 ln of x minus 1. That just comes down. This is simply 4/10 ln of, I'm going to substitute back in for u. So this is ln of x squared plus 4. And over here, we've got 1 over a, remember, tangent inverse of x over a. Right? If you didn't recognize that, hopefully you didn't go and do it. You wouldn't go and do a trig substitution on that, but you could. So 2/5 tangent inverse of x over 2 plus c. So that's your answer. So this particular problem had some nice twists and turns to it, but certainly you couldn't have gotten off the ground unless you were able to do algebra, and that really was this step where we grouped. Okay?